Howard, the meeting is really over, so we have time if you want to say, talk a bit more, because there are no more participants. I asked Chang Luk to
Yes.
To make the presentation. Are you there, Chang Luk?
Yes, I'm here. Can you hear me?
Yeah,
now,
we
yes,
can hear you.
we can.
Yeah.
Okay.
We can.
Okay.
So now I can. I'll share my screen with you. Okay.
Perfect. Sure.
First, I want to introduce the assembler. This assembler can be designed. Can be generated automatically by assembler. But first, you have to design your own assembler. Once you understand how to design a single instruction like this,
Chang, we cannot see your screen. If you can share your screen.
Oh, yes. See, can you?
No, yes, okay, perfect.
Okay, now, let's see. It's only a page of screen, right? Once you understand the instruction format for this one, you'll be able to design all the other instructions as well. This is the one this picture is the one I take from the website here. You'll find that the OP code structure of each individual instruction. From here, you can see this one is logical shift left, and it has 5 bits of OP code with constant. So we say this is 5C, and also a number with 5 numbers bit, and 3 RM bit, 3 RD. So we can say this format, this instruction format is 5C, 5 number, and 3 RM or 3M briefly, and 3 RD. Okay, all the other instruction format can be expressed like this. Now let's switch back to our main program. Here, this is the format of the one I showed. This is 5C5. Anyway, we can say this is a defining word. It is to define the assembler of this instruction. And I prefer to use algebraic assembler or style of notation. So we have 2 choices. You can use original mnemonic or use the algebraic assembler or assembly language. And also I had more than 5 or even 10 of the expression that can be used in my assembly language, including Forth virtual machine and virtual and math macro instruction, and also the postfix notation and infix notation. So it's really very different from the traditional one. From here, we can load it to the main program, the main system. Here I use Win32 Forth. I would say nobody else in the world use this kind of Forth again, Win32 Forth, the old version. But actually, I can execute it under Win 10 or Win 7, 64-bit system. So it's no problem. But you have to copy the main program from the one that generated by XP book, Windows XP or former version. But mine is okay to run in under Win 10, 64-bit system, and it works very well. And I use this for all the design of the cross compiler system, including the assembler, disassembler, and the cross compiler and decompiler. So now we are going to pass it to, okay, here. Now we can execute it by, say, this is a very basic, assembler that can use. We use postfix notation. We say 1, 2, 3, logic shift left. Okay, now it's okay. But where are we now? Oh, this is in Win32 Forth system. So we can still execute it. So here again, it's increment by 2, right? And we can see the object code that is generated here. We can say fetch and print it. So it's D1. So the same for the other, we can do it like this. This is the algebraic assembler that we can use it. The same number entered first. And now our address advanced by 2. So our new is here. Okay. Yeah, it's still the same. Or we can list all the command or the code that generated here. So we have 2 instructions. The first one is generated by this one. The second one is by this. Okay. Now this is the first thing you have to know, how to design an assembler. It's quite easy once you understand how to fill each bit region with the register. So 0, 2 is here, and 5, 3 is here, M is here, and the number is from A. We use hexadecimal system. So now we put all these together to get 16-bit of object code, and then in comma it to here. Okay, this is the basic. Now I'm going to switch to more advanced one. You see, oh no. I'll say this one. Okay. This one is the same as the former one, but we add here this line of program, and the other one here. These 2 lines are added to generate the disassembler when it is assembled the instruction. When we assemble this instruction, it will generate the disassembler like this one automatically without having to redesign the assembler. I would say this is the only one disassembler that can be designed or generated directly by assembler, I would say. So once you understand how to use it, and very simple, like this, then you will be able to design your own cross compiler. Once this one is executed, and then disassemble result, the result will be here. Okay, so now let's try to use this one as the source code. This one has been used in RISC-V assembler and disassembler design. RISC-V. I use this for all kinds of microcontroller like ESP32 or ESP8266, even Parallax, even MSP, both 30 and 8051, and also Cortex M0, M3, and 8065, 8051. Now, I'm going to load the program. See this one. Okay. XC1. Actually, I put all this in the GitHub, so you can see my program here. Now we can press any key. Okay. So now I'm going to load the source code of this one. This is the source code. We here only have 4 instructions here. So I'll just load one first, just to show you how one assembler can be designed by this. Oh, what? Oh, I didn't put the source code here. This is the source code of the defining word. We can say this one is defining word. So we can now load it first. Defining word has to be loaded first. And then we can use it as the defining word to develop the assembler of each individual instruction. Here. See? This one generate the one like this. And and here it has original mnemonic here. And the other one we can say original mnemonic of. I would say everyone can understand this very easily. See, the same like this one, but it has no original mnemonic. So we can choose between the original mnemonic and the algebraic assembler. And then from this, we have to load it to the system to use. So now I can load it. Okay, now it's been loaded. And the second one is also okay. But actually, I put all this in a file, not just by one by one. Okay. So we have 2 assembler being loaded. Now we can use it. Disassembler, this is disassembler, and the assembler is, this is the assembler. Okay, so we can use this the same like say 1, 2, 3. Okay, before we execute this, we have to know where we are now. We use hex here, prime, instead of here, because prime means the target image. Okay, so we have here, we can disassemble it, and we can see what we are here. Here is 0, but we can say 32-bit fetch. We can read it, right? The same like it was we have shown before, D1. And the same, we now can execute the same like this. The second one here. So the same, 2 will fetch it. See, the same. So it means that the 2 instruction has been, successfully compiled and assembled. So we have put all this in all this together. You see? The first is this one, right? Okay. The rest of this can be done the same like this. So we can now load this for this in this file DISXE2 to the system to verify. Include DIS. Yeah, it's okay. But the first two has been redesigned, so it's okay. So anyway, this is a very basic assembler, disassembler design. Once we have assembler being designed, then the disassembler can be generated automatically without having to redesign it. It's a big, engineering effort to do if you want to design your own disassembler. But the assembler like this one is very easy to design because of it's just you have just to fill it with the number. It's just the same like you hand manually, code the OP code. So it has no anything like swap over or rotate over all those things. So it's very easy to design this kind of assembler. And I have used this to design all kinds of assembler, disassembler, and now you can see. Oh, here. We have include file here. Oh, we have RISC file RV32 C type of instruction set. So you'll see the original instruction like this, original assembler. See? It's only about 600 lines of instruction, but it's only C, means 16-bit of instruction set. But all for other 32-bit, we have other files to use. And this is the STM103 eForth that I developed. I ported it from Dr. Tim's eForth, and I added a prog force and even must-be force to one chip. So I put all the program and the test file in the GitHub, so you can burn this into your blue chip. Then you can run 3 systems very easily. Okay, and when you see the compile system, the code compile system I designed to develop the whole program. When you see this one, you'll see it uses macro to express, all the assembly language program. But of course, not all the program has to be expressed like this. Anyway, you can see like this. This is tube, right? It's the macro of tube. And R6 equal to 556, RD, R0. So from here, you can see very easily. But you view the traditional one, I would say it will confuse me because of
the use of... This is okay. Thank you for presenting, Jean-Luc. I see we are very nice done. If you can share the file on GitHub with us, we publish this on the group.
Okay, thank you. Okay.
Thank you. Okay, guys, the meeting is over. We had a very nice meeting, and it lasted for over 4 hours. We started with an early Forth Cafe, very long talk and very interesting for me. So I thank you, every participant, very much. We are stopping the recording now.